Okay, so we're going to do what we call instantaneous rate of change or the slope. So the big deal, all these words are actually synonymous with each other. We're looking at the word slope, instantaneous rate of change, and the word derivative. So this is a hint right now. All these words are pretty much the same type of meaning. It's how fast something is changing. Instantaneous rate of change is what is the actual change at that very moment. The derivative refers to this rate of change, and this can be considered in Algebra 1 a slope problem. Okay, so if I give you a graph real quick, and then we give ourselves that easy one, let's say this x squared. As we move along the graph, we have different tangent lines. Okay, so if you pick a point, pick any point you want. Let's say I pick a point here. The tangent line, which looks like this line that right here, that tells you how fast the graph is changing. Now, is this graph increasing or decreasing, reading from left to right? Reading from left to right? Would you be okay that the graph is just going to start dropping? And this tangent line tells you what the slope, right, which is what the instantaneous rate of change is. How fast is that line changing at that very moment? And this is a slope problem. Now, our slope problems from Algebra 1 are referred to as f of b minus f of a over b minus a. That's how we refer to slope in Algebra 1. Great. In pre-calc and calculus, we want to change that. We want to say instead that this is referred to it as this different equation. We're going to switch it up a little bit. We're going to say, hey, instead of writing f of b minus f of a, we're going to say if I start at a, b is just a plus a little bit of h, which is in a sense our step. Right? To get to b, we just start from a and we count a little bit more. From a to b, let's say this is a and this is b. To get from a to b is just a plus h gets us to b, where this is h. Some separation. So if we write this in this other way, f of b, which is a plus h minus f of a over a plus h minus a. So please take a look here. It seems really confusing, but I just said if b is a plus h, b is a plus h, so all these b's become a plus h instead. Okay. Now I can simplify this and look at the bottom. Look at the a and the a. We have f of a plus h minus f of a over h instead. Okay, so we have one version of this and we have a second version. So both these versions will be very similar. F of a plus h minus f of a all over h is similar to us to just say instead f of x plus h minus f of x over h. Okay, would you be okay that these look pretty much the same, except the letter x becomes a and a becomes x? Okay, so here is our next step. How far is h going to be? Okay, so let's take this example. We have an a value. Let's start off at -1. Okay, we have let's start off at -1 here of the graph. And then how far do you want h to be? Well, if I want the tangent line right here, something like this, I can't make h equal to 0. We need some space because our formula says we have 2 points for h, right? We have 2 points here. Now, if the tangent line is really right here, it looks something like this. If I get too far away, no matter what, look, the tangent line is totally wrong now. The slope is wrong. Would you say that at this point, my slope is increasing or decreasing? The slope is supposed to be dropping, not increasing. So h has to be pretty darn close for this to make any sense. So in calculus, we cheat the system. And we totally cheat the system. And we say, how far is h? The limit as h gets closer to 0. In Algebra 1, we start off to say that you need 2 points to find the slope of a graph. In calculus, we say, hey, yes, you still need 2 points, but those points are so close together, they are practically 0 spaces away. And can we find the slope of something with 0 spaces away? Well, that's what we're supposed to prove now. So our first problem, I'm going to ask you, what is the slope, instantaneous rate of change of f of x equals to x squared at x equals to 3, okay? So if I go to my graph, let's go and take a look at my graph. At 3, let's move this to 3, x equals to 3. You can see that the tangent line is going up, right? See how it's going up? Okay, so I could try counting that, but let's go ahead and figure this out algebraically. We write the limit as h gets closer to 0 of f of x plus h minus f of x over h, which is our fancy way of saying slope. Okay, what's my f? My f is right here. So we have two versions. The limit as h approaches 0 of x plus h squared minus x squared over h. Now, this is actually the most confusing part for kids. When they're seeing this problem for the first time, they are super confused, like, what the hell just happened? I would like to rephrase it a different way. Can we say that's just f minus f? That's f minus f. I'm going to write this instead using colors. It's f red, oops, f red minus f blue. Okay, f red minus f blue. So if I write this instead, it is the limit, oops, it's the limit as h gets closer to 0 of red squared minus blue squared all over h. Red squared minus blue squared. But what's the red though? The red is just x plus h. So this is the limit as h goes to 0 of x plus h squared minus what's blue? Blue is just x minus x squared over h. You could also think of this as your upgrade versus your old stuff, OG function. The f of x is your OG function, and this is my upgraded function. Now, once you were in this step here, we could try plugging 0. And if I want to plug in 0, take a look. If I plug in 0 and 0, you end up getting x squared minus x squared over 0. Isn't that 0 over 0? And we talked about this being indeterminate. It means we can't have this. So when you're stuck with that, we don't plug it in. And instead, we try multiplying it out and see what happens. The limit as h gets closer to 0 of x squared plus 2xh plus h squared minus x squared over h. How did you get this part, Mr. Ko? Well, this takes us back to algebra 1. What's x plus h squared? X times x is x squared. X times h is xh. H times x is xh. H times h is h squared. And guess what? You have two of them. X squared plus 2xh plus h squared. Now, if you remember, square the front, square the back, and double the middle, that works too. That's how we ended it. That's how I was able to do it so quickly. Now, please take a look. We have like terms. We're always going to have like terms that we have to simplify. The limit as h gets closer to 0 of 2xh plus h squared 5 by h. We can now divide the h's out, h, and h. Hopefully you guys can see all those three h's. We are left with the limit as h gets closer to 0 of 2x plus h. Now, after we've simplified the h's, after we get rid of the h's, because remember that was our 0 over 0. We can now plug in our 0 here now. Answer is 2x. Our slope for the problem is 2x. But let's go back and read the question. What is the slope at specifically 2x? Sorry, at x equals to 3? What is the slope at x is equal to 3? At x equals to 3, we now plug in our 3. Our slope or instantaneous rate of change is 2 times 3, which is 6. That's the slope. If I go back to the graph here, does it look like 6? As close as we can get to, well, I can't get there. Does it look like 6? At x equals to 1, 2, 3, where's 3? Oh, 3 is right here. No, that's 2. I need this to be 3. Here's 3. Oop. What does the slope look like? It looks like it's pretty tough. Let's make it 0.1. Okay. What does the slope look like here? Let's go ahead and count it. The slope is 1, 2, 3, 4, 5, 6. That slope is 6. Okay, that's the slope of our tangent line. 6 over 1. Just to test this formula out, here's something kind of crazy. If we said the slope was 2x, okay, that's what the equation of the slope. We can describe it as a y prime in our fancy calculus way of writing things. Or let's just say m is 2x. What is the slope at x equals to 2? So the slope is 2 times 2 is equal to 4, right? Now here's the crazy part. If I go to my graph, and let's say my a value, my x is 2. I'm gonna go and show you something kind of cool. Let's zoom in. The slope is 1, 2, 3, 4 over 1. Check that out. That's the slope of my line, isn't it? Okay. What is the slope if I decide to say -1? What if the slope is -1? Let's go to -1. All right. So we can count this line here. The slope, looking in red, you guys aren't colorblind, but I am. The slope is -1, 2 over 1. Check it out. That's the slope here of my tangent line. Let's see if that holds true. If I said the slope, what is the slope at -1? That's 2 times -1 is -2. Oh my goodness, it's -2. So what happens is we create an equation that predicts all the possible slopes for this equation, x squared. Now, does this work all the time? Yeah, it does. But some problems need special techniques to solve them. So let's look at a square root problem. If I say what's the limit? Sorry, what's the, not limit. So find the slope of, let's look for an easier problem, of x squared of f of x equals to the square root of x at x equals to 4, okay? So let's go ahead and look at this graph here. What does that graph look like? Square root graphs aren't very hard for us to see, but let's go ahead and type this here. Let's do the square root. We're going to do x exponent of parentheses 1 over 2. Okay, so this is our equation, our 1/2. Now at x equals to 4, let's take a look at 4. That's my graph right there. We're going to stick at 1, 2, 3, 4. All right. So looking at the graph that's drawn, we can predict that the tangent line, the slope of the tangent line is going to be, see, 1, rise 1, 1, 2, 3, 4. Does that look pretty clean for you guys? You guys can agree with that? That looks like the slope of a tangent line, rise over 1 over 4. Now, my bet is that me doing the slope formula is going to give me the same answer. So let's go ahead and set this up. This is the limit as h approaches 0 of f of x plus h minus f of x all over h, meaning my new versus my old point. And what's the new point? It's just h away. How far is h? It's 0 spaces away. But that's impossible. You can't go 0 spaces away. You're right. But that's what limits allow us to say. It's not what is it, but what should it look like? What does it seem like it should be? So the way we set this up is we write our new and old functions directly into it. So f of x plus h, which is just the square root of x plus h minus the original x squared of x. So it's my new versus old. Please take a look. They both have the same structure. It's the new minus the old. The only difference is that the variables inside has changed. The new versus the old. All over h. Now, if you remember square roots, we talked about multiplying by something called the conjugate. And that's actually the trick here. The trick to these problems is multiplying by the conjugate. And if you remember what the conjugate was for this problem, it's the square root of x plus h plus square root of x over the square root of x plus h plus the square root of x. Folks, that is what we do the conjugate. Remember the sign changes from a plus to minus or minus to a plus. That is the main difference for both of these. Now, please don't freak out. You might say, Mr. Go, that's not a lot of work, but I'm gonna tell you, let me remind you a trick here. What is x plus 1 times x minus 1? Are these the difference of two squares? So this becomes x squared minus 1. No work needed, just square the front and square the back with a minus sign in the inside. That's exactly what's going to happen here. We're just going to the limit as h gets closer to 0. And what's a square root times a square root? Since they're exactly the same, they're going to cancel out. Just x plus h. No joke, that's really what it is. Square root times square root, that's going to be an x in the back. And the middle term all cancels out. The square root and the square root are both going to cancel out because it's plus and minus. Which is perfect for me because I don't want to do the work. On the bottom, we're just going to copy. Please just copy h parentheses square root of x plus h plus square root of x. We are not going to do any work on the bottom. Please trust me on this. We're not going to do any work on the bottom. We have like terms on top. Take a look on the problem. Do you see any like terms up here? You see an x and x. Those are going to simplify out. Limit as h gets closer to 0 of h over h. Ooh, you see h over h. Do you think what's going to happen to those h over h's? What's going to happen to the square root of 8? What do you think is going to happen to those h's? The h's are going to cancel out, right? Simplify out. And we are left with this crazy problem that's left over. The limit as h gets closer to 0 of 1 over the square root of x plus h plus the square root of x. Now here is our next dilemma in this problem. What happens next? We got rid of our h's. The next step is just plug in the 0. And when you plug in the 0, if x plus 0 is just x, we end up with twins. Since the twins are the same, like terms. So the slope is 1 over 2 squared root of x for f of x squared root of x. Okay. Now, we asked the question, what is the slope at 4? What is the slope at x equals to 4? We just plug it in. 1 over 2 squared root of 4 is 1 over 2 times 2. And guess what? It is what our predicted slope was. It's 1 over 4. What about if I said slope at x equals to 1? Fine. Since we have the final equation all done, our slope is 1 over 2 squared root of 1. That's 1 over 2. Okay, what if I ask you for what's the slope at the square root, at x equals to 9? 1 over 2 squared root of 9 is 1 over 2 times 3 is 1 over 6. Now I want to prove to you guys with the graph that we have that this is exactly going to be proven by our graph here. So at x equals to 1, let's move that a value to 1. Let's take a look at what the slope is. and start counting, the slope is 1 over 2. See that? Rise 1, run 2. Bam, that's the slope, which is what we said, right? We said that the slope was going to be 1 over 2. What is the slope when x is 9? This is a little tougher. Okay, we made it to 9. Now, what's the slope going to be? I'm actually going to go backwards, but hopefully you guys can recognize this. It's going to be from, let's pick this point here, rise 1 and run 1, 2, 3, 4, 5, 6. 1 over 6, 1 over 6. And guess what? That was actually our predicted value here. So by us using this fancy way in calculus of finding slope, we're able to determine what the slope of these graphs are. Now, there's actually only one more way for us to talk about finding slopes. Is what if those are fraction? And that's something that we're not going to worry about in the scope of this class, okay? But we've done fractions before. It's not that there's any different to the skill. Just multiply to get rid of the fraction. So we multiply by their reciprocal. All right, that's it. That's what your work is going to be today.